Hello guys, in this video we're gonna solve a parallel circuit using symbols, right? So we're gonna start using a battery. Now we are going to, let's check the value of the battery here. The value, now we go to our tables here and we need to use a 10 volts battery. So as always we can click on the battery and then we can change this number to 10. And now let's go and check and place the resistors in place. The first resistor is gonna be a 2K resistor, so let's say 2 here, and now we're gonna drag another one here and it's gonna be a 3K resistor. So I click here and I change the number here. Alright, now it's always useful to have a switch in series with the battery so we can control when we want the circuit to be on or off. So let's do it like that. As these resistors are going to be in parallel, we're going to connect them together. Okay, both terminals, this terminal and this terminal are going to be connected together. So when we move this one here, right, and when we close the circuit with the battery, these ones are connected in parallel. So now we click here and we need to check the voltage that is being applied to this resistor here and the current that everyone is receiving, right? So as we were using volts or voltmeter in order to measure the volts, now we are going to use an ammeter in order to check the number of electrons, the current that is flowing through this resistor and through this one. We can just place the cursor here and we see that the battery is giving out 8.33 milliamps, and if we place the cursor here, this one is getting 5 milliamps and this one is getting 3.33 milliamps. So the current that is being generated by the battery is divided between these two resistors. The one that has a lower value is getting more current than the one that the value is higher. We can still measure that we can also measure this with an ammeter. So we can delete this and we can delete that, and we can place this here. We can place an ammeter here. Let's place one here, and let's place another one here, and we can close the circuit here, and we can close it here. And now we see that this one is measuring 5 amps and this one is measuring 3 amps, 3.33 amps. In order to measure the voltage, we can use the voltmeter, the one we were using here. Just with one is gonna be okay, because we just need to measure 1 volts, one voltage here. So the one from this part of before the resistors, and this one after the resistors. Okay, so we can see that the voltage that is being generated by the battery is 10, and the voltage that is being consumed by these resistors is 10 as well. Okay, so everything that is being produced here is being consumed in both of the resistors. But the current that here we are generating 8.833 milliamps, that current is being shared by this one and by this one. Alright, so this one is getting 5 milliamps and this one is getting 3 milliamps, 3.33 milliamps. So now let's complete our table. Alright, the voltage of the battery is a 10 volt battery, so this is very clear, this is going to be 10. The voltage across the 2K resistor, as they are in parallel, is again 10 volts, and the voltage across the 3 ohms 3K resistor is 10 volts as well, because in a parallel circuit every component is subjected to the same voltage. The current that is being generated by the battery is 8.33 milliamps, and then that current is shared by this one and by this resistor. Okay, the first one, the lower one, is getting 5 milliamps, and the higher one, okay, the higher value is getting just 3.33 milliamps. Okay, so now can we check this, that the voltage across the 2K resistor is the same as the voltage across the 3K resistor, and is the same as the voltage generated by the battery? Yes, 10 volts everywhere. Okay, 10 volts are being generated here, and 10 volts are being consumed here and are being consumed here. Alright, now we can see if the Ohm's law is followed. Okay, so the current generated by the battery is the same as the current through this one plus the current through this one. Yes, that is true as well. So the current, this is 8.33, and then this is divided by 3 plus 3.33. And now you can always apply the Ohm's law, that the voltage across the 2K resistor is the current through 2K resistor times 2K. Let's see if that's true. So we know that the current that is flowing through the 2K resistor, let's check it, is 5 amps, so 5 milliamps, sorry, so 0.003, and the value of the resistor is 2K, 2000, right? So we have 10 volts, okay, so that is true. So this one is consuming 10 volts, and this one is consuming 10 volts. You can check it yourselves. Okay, I hope this helps. I'll see you in class.